Okay, cool. So this is just going to be assignment 4. And I'm doing it in 19.1 because I had issues in 19.0 when it came to generating results. It would get stuck on, not the mesh analysis, but I get stuck somewhere and it wouldn't run. So I'm just going to give it a bash 19.1. Hopefully it works this time. So just going to drag the file we got and click up straight into Workbench. It'll create a geometry. Cool. And I'm just going to double click on this geometry to open SpaceClaim to do the editing that he wanted us to do. Okay, cool. Now we're up and running in SpaceClaim. We went through the whole importation process. So now it's loaded it. Craig did all the splitting and split the vessel in half, split all of these plates up, so the analysis in thermal will be easy. I'm not quite sure exactly why he does it, but you need to do it for the analysis. So what he wants us to do in SpaceClaim is add a lip and a thickness to this mid surface. Have a look at the document to see what dimensions I'm going to use. I'm not going to explain how I got them, I'm just going to do it. So this is the way I'll do the sketching here. So we're going to go to this orientation. I'm going to use the offset tool, and if you click on this line, I'm not going to show it, but it draws in the plane of the top line, so it's in the correct plane. I think it's 45 millimeters. Cool. And now you can see there's only one line in this new sketch. You need to have a closed sketch to pull, otherwise it won't pull correctly. So let's offset tool again, back to 45. So now we've got that closed part. So now we're just going to add some lines. Cool. There to there. So now we've got a closed sketch in the correct plane. I'll show it to you now. There we go. So it was in the correct plane. So now we're going to go 3D mode, pull. So we're going to drag this key. Whilst I'm holding the mouse button down, I'm just going to enter a thickness, 20 mils. Cool. And now he wanted us to add a thickness to this, so I'm going to select, whilst I'm pull tool, I'm going to select this, and then drag inwards. And then the thickness is 10 mil. Enter it whilst holding the mouse key down. Enter. Cool. So now I gave it a thickness. I'm going to do something. He didn't say you have to do this, but I'm going to do it anyway. I'm just going to combine these two whilst holding down the control button, just so it makes it a little bit easier to reference everything. Otherwise you got so many different surfaces floating around. Next, he wanted us to split this and this down the center. So how you do that is you'll need to create a reference plane. So go into plane, and then I'm going to click on this here, click on the coordinate system as a whole, go back to select, and then we don't want this plane and we don't want this plane, so I'm just going to get rid of them. So now we got the right plane to do the splitting, so just get the orientation right. Now I got the plane to do the splitting, so I'm going to go split body tool, because it is a body. So we're going to select the body in that stage, and then select where to cut. There. Same thing for here, select the body, select the plane, cut. Cool. So now we split all of that nicely. Now when it comes to topology sharing, you need to be aware that in the tree of all the parts, let's just get here done. Okay. In this tree, everything that is the vessel must be in the same tree, because if you have a different tree and you share the topology, you're going to get very weird contacts when it comes to mechanical. So what we did now, these two surfaces, let's go back to select. What we did now on these two surfaces, it didn't add it to the vessel itself, so we're just going to drag it into vessel. So now we got everything that is the vessel in the vessel tree supports 1 and 2. So let's just go back and get rid of that. And now on these groups you share the topology, so it must be one group, otherwise, yeah, like I said, you're going to get very weird contacts when it comes to mechanical, and then the stresses won't work out properly. Come on, share, share, share. Okay, that's all done. So I'm just going to save a copy of this in the Ansys format, desktop, Ansys. Okay, so now we've got a saved version in the Ansys format. Now we're going to go back to Workbench. Now that we've got the geometry sorted, I'm going to start with the steady state thermal analysis, which is what you wanted. So just drag it onto geometry. So it pulls your geometry through. If you ever want to go back and edit the geometry, edit it here, because then it'll move through the whole project, because we're going to have a steady state structural, I think, later on. So yeah, let's double click on model, and we're going to open it in mechanical and start with the analysis. Okay, now that we're up and running in mechanical, I'm pausing and unpausing the video whilst it loads, so you don't have to watch the loading screen. It's a bit pointless. We'll start with geometry. We've got question marks on all the geometry here because there's no thickness that's been assigned. If you ever wonder what the question mark's from, just click on it and it'll highlight what it wants. It's not always thickness, it might be something else. So that's how you find out where the question mark is coming from. So let's just assign a thickness of 10 mil. I think that's what he wanted us to do in the assignment. 10 mil, same thing. Okay, cool. So now we've got ticks. So the first thing I'm going to do is assign symmetry, because yeah, we've halved the pressure vessel. We need to tell it where the symmetry is. So first things first, I'm going to suppress the two supports. So we just left with the pressure vessel. Suppress those. So now we've just got this. And now let's start with symmetry. So we're going to insert symmetry. Will pop up here under coordinate system. Insert symmetry region. Now we want to select the face that runs all the way around here. So we're going to select face. Now we're going to zoom up. It's really quite tedious, I'm not going to lie. We're going to select all of these whilst holding control. So let's go 1, 2, go. I'm not aware of any other way of doing this. I really wish I knew. It'll be a lot less painful. If you know of another way, don't judge me. I'm just doing it the way I know how to do it. Okay, almost there. Yo. Selecting everything. Make sure there's no discontinuities, otherwise it won't work correctly. Okay, so it looks like we've got it all. Yep, we got it all. So you click there and you click apply. So now we got that symmetry region, which is cool. So now we're gonna unsuppress these and then suppress the pressure vessel. So now we can get same symmetry region, because these have been cut in half also, remember, so we need to tell the program where the symmetry is. So instead of faces, these are vertices. So we're going to go here to edge, and then we're going to insert same thing, symmetry region, and now we're going to go and select all these edges here. If I'm not mistaken, there should be 10, but let's see now. So selected all of them, apply, and yeah, we got 10 edges, so I think that's correct. Go back, unsuppress the pressure vessel. So now, yeah, we've sorted the symmetries. Now I'm just moving down as we go. So now we're going to start the mesh. Something quite interesting happened here. I'm not quite sure why. Yeah, I don't know. With the mesh, you wanted it to be a sweep mesh, so obviously no sweep mesh here, so we're going to have to go to method, and then we're going to select, I think you select bodies or faces. I'm not quite sure if it matters or not, but I'm just going to select bodies, select all of these. Cool, let's just check, select you, so make sure it's only pressure vessel, not the supports and not the neck, because there's quite a sharp discontinuity here, so the meshing software won't really know what's going on when it tries to generate the mesh. Click apply there. So now let's just generate it. Something quite interesting happens here. It I didn't select these bodies, this body and then the support body, but it gives it a mesh anyway. Yeah, so it's carried the mesh over, which I found quite interesting. I don't know if that's correct or incorrect, but you know, I'm just going to run with it. Yeah, so now let's move on to the thermal analysis. Everything else, as far as I'm aware, is up to scratch. So initial temperature. Oh, we're in Kelvin. Okay, so let's go to units. Degrees Celsius. 25 degrees Celsius. That's cool. And then first thing they say, is obviously initial temperature, and then the temperature within the pressure vessel. So because it's within, we're going to select the face because it's only on the inside. And we're going to select all of these suckers, these two, and then awkwardly enough we have to go and find these two as well because it's still within the pressure vessel. So we've applied the geometry, and they said it was 90 degrees Celsius if I'm not mistaken. Okay, so we've inserted the temperature and initial temperature, and now they've said there is a convection. Let's just get this orientation right. There is a convection on the outside of the pressure vessel, so we're just going to go steady state thermal, insert convection. We wanted the face because it's only the outside. I'm just going to select all the face bodies. Because the temperature is applied on the inside, I'm going to select convection on those faces as well because the temperature is applied on the other side. Don't select these because that's a part of the base. I'll get to that now. The film coefficient, so the convection coefficient, is watts per meter squared. So it's 50. If you don't have watts per meter squared, just go up to units, and this is the one I'm using. This is what you could be on, watts per millimeter squared, but yeah, I keep it up there. Now the second convection insert convection is on the base, the support structure. So let's go to geometry and suppress pressure vessel. Yeah, so you're just left with that. So let's go box select the entire body. Let's actually just stick with faces. So we go to convection 2, geometry, select it all, apply, same thing, 50 watts per meter squared. So now let's go unsuppress pressure vessel to get it back, and I think that's everything I have to do. Just give me a sec. Okay, yeah, so that is everything. I'll stand to be corrected if it is wrong, just let us know. So let's insert temperature graph so we can see if it's working. So I'm just going to click on solve. This is where 19.0 fell over for me last time, building mathematical model. It didn't do, so yeah. Okay, yeah, as you saw, got that error there, which is really weird. I don't really know why it gave that error. So I think it had something to do with me having the geometry open and space claim at the same time. So I went back into Workbench and then set up date project from here, and I think it pushed the geometry through and then ran the analysis, and it went through. Okay, I had a little panic attack there, but yeah, sorry about that. So everything up till now, I believe, is correct. You can see, it kind of makes sense because the base is cooler than the pressure vessel. It's saying the pressure vessel is 90, pretty much, and then the base gets gradually cooler as you move down, which is right. So now we're going to start with the steady state, static structural. Sorry, what I was saying. Drag it onto solution. Okay, we've been blessed with the presence of Andy Malley, the YouTube channel.
What's up, boy?
Okay, so now in the static structural, we'll start off with the hydrostatic pressure, so the pressure within the vessel, the water pressure, whatever. Okay, so we're going to go to faces and we're going to go single select, holding down control, select everything inside the pressure vessel. What am I doing? And bear in mind it's also, you know, up here. The pressure acts up there. Okay, cool. So we're going to define it by a component. And we're going to put the Y component as the mass of water, which is 997. You can put 1000, but no, what am I doing? Okay, yeah, sorry, I inserted a force, not a hydrostatic pressure. That's why it wasn't really making sense. So same thing. Select the geometry and face, holding control. We're going to select these, and then also these silly little faces up here.
Or is that a cylinder?
Well, it's selected.
Yes, yeah.
Those silly little faces up there. Click apply. Fluid density is water, 997. Okay, now we're going to assume the pressure vessel's full to the top of the opening. So we're going to go define by components, and the Y component's 9.81, but we need to change the units. Hang on. Units metric. No, okay, 997. Make sure the units are right. I've done this so many times. Y component gravity is acting down, minus 9.81.
And it's got to be a
comma 81. Okay, so we've got gravity, and then the Y coordinates is right to the brim, so it's 0.91. You can work that out yourself. It works out to be correct. So you can see hydrostatic pressure acts to the top. Okay, next thing is the pressure within the vessel. Same thing, just select everything on the inside. Such a pain, but you have to do it every time. I'm going to select these as well. Such a pain, yo. So select these, apply. So now we got everything within the vessel. That's 1 MPa, correct? Yeah, it's 1 MPa.
Yeah.
Okay, let's change the units. 1. Is it in the right direction?
It might be -1. Where's the arrow? Oh, no, it is right.
It is right, but why is it so small?
Cool.
Okay, so that's there. Okay, so the next thing we have to do is insert standard Earth gravity up here. We're going to tell it it's currently acting in Z. We don't want it in Z, we want it in Y. So we'll change it to negative Y. And you can see that arrow's right.
It's okay, she's probably like a...
Okay, the next thing the TA did in the tutorial was quite interesting. We're going to apply a whole lot of moments and forces on the top of the pressure vessel. Now, what he did was move or create a coordinate system that moves up to that point, just to make referencing the forces easier and simpler. You reference it to that coordinate system. So to do that, you're going to go to coordinate systems, right click, insert coordinate system. Don't want to define it by geometry, you want to define it by the global coordinate system, and then its position is 0.91 meters above meters units, 0.91 meters above the other coordinate system. You can see that does make sense. So yeah, we've got coordinate system. It just calls a coordinate system, which is cool. So go back down to static structural. We want to insert a force on the top of the pressure vessel. It's going to be acting, just going to face those two faces. Zoom out a bit, pan, apply. We want to define it by a component. Come on. and we want to define it about the coordinate system, so the new coordinate system we made. It's acting in the Z direction and its magnitude 500 newtons, I believe. If I'm incorrect, tell me. So yeah, it makes sense, it's there. The next thing they did was they added a moment also. Didn't really make sense, but they wanted us to add a moment. Same thing on those two surfaces. Blah. It's not a vector, it's a component. It's about X, yeah, so it's going this way, and it's 500 Newton per meters, I believe. So yeah, that does make sense, and I think that is right. Okay, now that we've got all the forces, moments, and whatnot added, you can see this little question mark by imported loads from the steady state thermal analysis, and that's because you're applying a temperature or a heat to the inside of this and a pressure. Everything's revolving around the pressure vessel. Not much is happening with the legs because no temperature is applied to it. So it's trying to import a temperature body from the previous one, including the supports, and it doesn't like that. So what you have to do is you select bodies. I'm just going to select all of these, excluding the supports. We want these. I'm going to select the bottom because bodies. Yeah, that's how it wants it. Click OK. Now you can see it's the question mark's gone, so that's great. Let me just run this to see if I've done everything right. Okay, yeah, ran it and it didn't like. It says there's a UZ degree of freedom problem, which means that I haven't added a support, obviously. So let's go fix support. And the base is just like we did in the other assignment. It is on face selector, yeah, face select. Cool, and let's try it again. Okay, so this time it ran, awesome. So we're a long way down the track for this thing not to work. So let's insert deformation and let's insert stress or masses. Yeah, and let's just go. I'm just going to resolve the whole project. Okay, so now we've gotten something like this. Let's just get the orientation. Okay, so we've got something like this. I'm going to remove the wireframe so it's a little bit more apparent what's going on, and then I don't want auto scale, use tree scale. So that's how much it's actually deforming, and that's the actual stress. So you can change the zoom of the force in and out as you require to get what he got. Now you can see there's a little bit more of a stress concentration on one side than the other. That's what we expect, because the moment and the force acting on the top are going to be inducing stress concentrations on the one side. The only thing that I'm confused about when reaching the end is the deformation, and also let's go stress, and the stress appeared to be completely symmetrical about the neck of the pressure vessel. And you know, if you think about it, there should be more stress on the one side than the other because of the force and the moments acting in the same direction. So if you look in his document, it shows that there's more forces in the one than the other. So if I made a mistake, or you can figure out why this result is completely symmetrical, let me know. Otherwise, that's it for now. Yeah, I hope you guys do well on this.